Gas laws are the relationship between pressure, volume, and temperature. For Boyle's law, it states that the volume of a gas at a constant temperature is inversely proportional to the pressure applied to the gas. What does this really mean? It simply means that as the pressure increases, the volume decreases at a constant temperature. Constant temperature means the temperature was neither increased nor decreased. You ask yourself, how can I increase the pressure? Simple. First, you know pressure is simply a force you apply over a particular area. That's why pressure is force divided by area. Through a demonstration, let's say you have a gas in a container at a constant temperature as shown on the screen. Then, pressure is applied on top of that container that was filled with gas. The pressure applied is in form of the weight you see. You notice that the more the pressure, the more the gas is compressed in the container, thereby reducing its volume. So, if you want to apply a force on these containers, you can do this by adding weight, which serves as the force operating under gravity, on top of the container, which serves as the area, which results to the increase in pressure in the container. The unit of pressure often used are Pascal, standard atmosphere, and torr. 1 atm is the average pressure at sea level. It is normally used as a standard unit of pressure. Sometimes you see 760 torr. It's the same as 1 atmosphere. Let's check this out practically. Take a look at the setup. The container containing gas particles has a movable piston on top of it, so that if we put a weight, it can press the piston downwards. By the side, there's a barometer to measure the pressure inside the container. Take note of how the gas particles just move randomly or calmly when there is no increase in pressure. By the other side is a thermometer checking the temperature of the gas. You can see by the side we have two weights. One is measured to be equivalent to 2 atm, and that's 2 atmosphere, and the other is an equivalent of 3 atmosphere. Remember, the bigger the pressure, the smaller the volume of gas occupied. The initial pressure P1 is at 1 atm. That means it's still under the normal atmospheric pressure. And the initial volume at these particular pressures, 3,000 liters of gas, which will serve as our V1. Let's check out what happens when we apply pressure of 2 atmospheres. This container contains 3,000 liters of gas, still operating at atmospheric pressure. This shows that the weight moves on top of the container and moves to half of the container. Remember your Boyle's law, that when the pressure increases, the volume decreases at a constant temperature? And you saw that initially the pressure was 1 atm, but when we kept the weight, the pressure was increased to 2 atm. You also saw that volume before was at 3,000 liters, then it reduced to 1,500 liters. There's a general formula you can use to calculate these by yourself. You can see it above on your screen. P1 multiplied by V1 is equal to P2 multiplied by V2. The P1 is the initial pressure, and the V1 is the initial volume. The P2 is the final pressure, and the V2 is the final volume. So, let's say you're given any of the parameters. You can easily know how to find the missing one. Can you figure by yourself what will happen if we put on the 3 atm? Can you calculate where the volume of the gas will be compressed to? Get your paper and pen and calculate using the formula above to determine V2. Once you are done, click the 3 atm button to see if you got the correct answer.